Hello everyone. So in the last video we have discussed about the balanced inventory. We have seen certain rules of creating a balanced binary tree. The rules were like the root, if it is not a leaf node, should have minimum 2 children and maximum they can have m children. All the leaf nodes should be at the same level. All the nodes except the root node must have m by 2 seal minus 1 keys, must have minimum this much keys. All the non-leaf nodes must have m by 2 seal children, must have minimum this much children. And all the non-leaf nodes must be at the, all the leaf nodes must be at the same level. So we will be doing certain operations like insertion and deletion in a B tree. Insertion into a B tree is very simple. Let us look at the algorithm. Attempt to insert a new key into a leaf. If this results in leaf becoming too big, split the leaf into two and move up the middle element to the parent. If this again results in parent becoming too big, split the parent into two and move the middle key element up. This strategy might have to be repeated all the way to the top, and if necessary, the root is split into two and the middle element is promoted to the new root, making the tree one level higher. See, insertion is very simple. When you are inserting a new node, insert it to the leaf. Check whether that insertion is making that node too big. If it is making that node too big according to the rule, just split the node and take the center element up. Again, check the case. If it is making the parent too heavy, again split the nodes. So let us see example. Construction of a B tree of order 3. So rule is every node except the root node can have m by 2 minus 1 keys, right? It can have at least this much of keys. So 3 divided by 2 is 1 point something. Seal of this is 2 minus 1. That means at least 1 key. It should have at least 1 key and 2 children's, right? So let us now insert 40. So 40, at least 1 key it is having. So 40 can be inserted directly. Every node can have at least 1 key, or maximum it can have m minus 1 key. M minus 1 is 3 minus 1, that is 2. The maximum they can have 2 keys. So next I'm inserting 80. 80 can be inserted because maximum a node can hold is 2, since we are creating 3-way tree. Let us now suppose we are inserting 10. So let us now suppose that we are inserting 10 in this particular node. Then it becomes 10, 40 and 80, as we have to insert it in proper order, 10, 40 and 80. 10, 40 and 80, we know according to the rule, the keys can be maximum m minus 1. That means 3 minus 1 is 2. So it cannot hold 3 keys in a node. That means this node is becoming heavy. Now we are going to split it. Splitting means take the central element. If it is 10, 40 and 80, central element will go up. Central element is 40, so it will go up. Towards the left of 40 will be 10. Towards the right of 40 will be 80. So this is how we are creating. Now see, this is a B tree. All the leaf nodes are at the same level. Every node is having minimum one number of element. Let us now suppose now we are inserting 20. Since we have to insert a new node to the leaf, so it is less than 40. So 20 will come here. A node can hold maximum 2 keys. So this node is okay. Again, I'm going to insert 60. 60 is greater than 40. So it will come here. A node can hold maximum 2 keys. So we don't have to do any kind of splitting. Now I'm going to insert 30. 30 will come here. Since 30 is less than 40, so it will come here. 10, 20 and 30. Insertion of 30 is making this node heavy because it cannot hold 3 keys according to the rule. So we are going to split this. Splitting will take 20 here, and then 10 will be towards left of 20, and 10 will be towards left of 20, and 30 will be towards right of 20. So this is the case. I have inserted 10, 20, 30, making this node heavy. 20 will go up, so 20 is coming here. It will be 20, 40. So towards the left of 20 will be 10, towards the right of 20 will be 30, and 40 right is having 60 and 80. So now I'm going to insert 100. inserting 100 will be here, making this node heavy. So I'm going to split it. 80 will go up. Towards the left of 80 will be 60, and towards the right of 80 will be 100, and 80 will go up. Once 80 will go up, this is making this node heavy. So again, I'm going to split, which will increase the height of my tree. So 40 will go up. Towards the left of 40 will be 20. Towards the left of 40 will be 80. So 40 will go up. Towards the left of 40 will be 20. Towards the right of 40 will be 80. And towards the left of 80 is 60. And towards the right of 80 is 100, as we have split that node also. Now let us suppose I'm inserting 50. So 50 will be greater than 40. It will be less than 80. So it will come here. No need of splitting the node because it can hold two keys. Now I'm going to insert 70. Let us now suppose 70 will come here. It is less than this. So if 70 will come here, it will be 50, 60 and 70. It will make this node heavy. So again splitting, 60 will go up. So this will be 60 and 80. Towards the left of 60 will be 50 and towards the right of 60 will be 70. So this will be my case. 60 will go up. Towards the left is 50. Towards the right is 70 and 80 right is 100. You can see this once again. We have inserted 70, which is making my node heavy. So I'm splitting it. 60 can go up. This node is capable of holding two keys. So it can hold this key. Again, towards the left is 50 and towards the right is 70. Now I'm going to insert 90. Inserting 90 will be here. This node is capable of holding two nodes. So it is okay. So insertion is very simple. What we have to do is we just have to insert a node. We are going to check whether inserting that node is making that node heavy. If it is making that node heavy, we have to split that node. Splitting that node means you have to take central element up and then you have to divide the node. Again, you have to check if the splitting is making the parent node heavy. Then again you have to split the nodes, which can make your which can increase the height of your tree also. But finally, you can see at every point after insertion, it is a B tree. Let's see whether this is a B tree or not. Each leaf nodes are at the same level. If root is not a leaf node, it can have minimum 2 children. Every node will have minimum m by 2 minus 1 keys. M by 2 seal, that means 3 by 2, which will be 1 point something. That means 2 minus 1, 1. So every node is having at least one key. All the non-leaf nodes, next rule was all the non-leaf nodes must have at least m by 2 children, m by 2 seal. That means at least they should have two children. So they are having at least two children. And the keys are arranged in some order. Every key is arranged in some order. So this is finally, it is a B tree. At every point of insertion, it is a B tree. So you can check this once again. Please try this example. Take pen and pencil and try this example. I will be giving you the solution of this in subsequent videos. So please take pen and pencil and try to do insertion, which is very simple in a B tree. So we will be looking at the deletion in B tree in the subsequent videos. Thank you.